Okay, recap chapter 5. Previously, we stopped at these slides. So when it comes to chapter 5, rigid body, when we look at the question, first we need to ask ourselves, how's the motion, how's the rigid body move? There are two types of motion. One is translation. Translation means without orientation of the object, it moves in the straight line. And one is linear motion, right? Linear motion, translation also, right? Translation have two, rectilinear motion and collinear motion. Another one is rotation, okay? Rotation, there's an axis. How you know there's a rotation? Use your right hand rules. Use your right hand rules. Try to find the axis of the rotation. And then there's a mix, general plane motion. General plane means it combines translation and rotation together. Okay. And two important equation for this chapter is you have to relate rotation, which is omega, with the velocity. V equal to omega r. Another one is you link the angular acceleration, which is rotation also. Rotation motion, omega and alpha, with the linear acceleration, a equal to an and at. When you see the motion is in circular motion, then you need to break your acceleration into normal and tangent direction. And you know that you are now looking at rigid body. Rigid body have rotation. So when you rotate, you can no longer use the normal acceleration. You have to link the acceleration with omega and alpha. So these are the two equations that is important. Okay. So how you know this is chapter 5, rigid body question? You will see angular something. The question will ask you angular something. Okay, or you see angular acceleration, or you see something that is round, then it's turning, then it give you acceleration in the theta dot, and so on. So is chapter 5 question. So same, you got look at example number 2, which is a motor like in the figure. So it run from A to B. So A will turn and then B will turn. So a motor on the top used to turn a wheel. A is a motor, B is a wheel, attached to a blower contained without housing. If the pulley A connect to the motor, begin to rotate from rest. So you have V 0 with the VO with equals 0 with the constant angular acceleration. When you see constant angular acceleration, it will be the same as chapter 1. When you see constant acceleration, you can use the normal normal equation. Just change the chapter 1 equation into alpha omega. So, and also theta. Okay. So this one is given alpha equal to 2 radian per second square. Again, rigid body normally you are using radian per second. Radian per second. Determine the magnitude. It asks you to find the magnitude because you're still dealing with vector. So vector and magnitude. Magnitude of velocity. So basically this equation. This is scalar. Okay. When you see a cross means you need to find the vector, vector form. But usually it's sufficient to use V equal to omega R to find the velocity and acceleration of point P. It asks you to change acceleration. So again, acceleration, we have one more equation. A equal to an and at or at an. Just need to make sure don't confuse between the tangent and normal. Acceleration tangent will be alpha omega. Normal one will be omega r. Okay, so don't confuse between normal and tangent. Okay, after the pulley have turned 2 revolution, 2 revolution means 360 multiplied by 2, or if in this kind of question, you need to use radian. 1 revolution equal to 2 pi radian. So this one, we have turned 2 revolution. Okay, 4 pi. Okay. Assume the transmission belt does not slip. Transmission does not slip means there is no loss of energy, because later, in the later section of chapter 5, you will have a scenario where the belt slip. When the belt slip means that you will see efficiency already. Okay, so later we'll go into that. So how do we solve this kind of question? Your focus will be in point P. Okay. So A will give you some information. You have the alpha. You need to transfer the energy to B. But you know that belt doesn't change. It's like a rope or pulley question. The total length still the same, right? So you just change the ratio of the rotation. Okay. So first you convert the angular motion into radian. So the rotation of A, it tell you after pulley have turned 2 revolution. So A is turning, right? 2 revolution is 4 pi. Okay, 4 pi radian, or you can put as 4 pi radian. Then since A is constant, you can use the 3 Newton equation. Which in this case, we are interested in the change of angle, or the S. In this case, in chapter 1 is S, displacement, but in rigid body displacement, it become angle already. So you use omega square equal to omega O square plus 2 alpha and the change of angle. Okay, so it will be similar like chapter 1, but you just change the velocity into omega, alpha into acceleration into alpha, s into theta. Okay, so you substitute the value. You want to find the omega of A. Omega O 0 because it do not rotate. Alpha, it tell you already at a constant angular acceleration. So you substitute 2. Theta, you already find already. Theta, it change after 2 revolution, the angle change 4 pi radian. Okay, minus the initial. You don't know the initial. Initial is 0. Okay, initial is 0. So from here, you should able to find your omega A. Again, you're dealing with square. You're dealing with square. You have to choose either positive value or negative value. You're dealing with angle. All right. Okay. So again, for this module, minimum 2 decimal place, maximum 3 decimal place. Unit should be always at the end of your answer. If in your calculation steps you do not put unit, I still can close one eye. I still can give you pass. But when you arrive at the final answer, please put unit. Please put unit. And if can, put the direction of your answer. Whether it's go to the right, turning clockwise, anti-clockwise, put behind the answer or before you start. Okay. Okay. Yeah. Later during the short break, I will distribute your test one. You will see some of you lose mark because you don't write numbers. And because some of you, your handwriting so bad, I cannot read properly. 9 becomes 0, I will give you wrong answer. 6 becomes 0, or 3 become 8. You do not write properly, I give you wrong answer. Okay. And if you need to be careful on your handwriting. If I cannot read, I cannot understand what you write, I just skip marking. Okay, so once that you find the omega of this one, okay, omega of this one. So in chapter 5, the steps will be the same as chapter 1 to 3, only that you convert your diagram into V into omega, A into alpha. That is the only difference. Okay, since the transmission do not have slip, so whatever turn change here will be the same as here. Meaning velocity here will same as velocity here. This belt move how fast is the same. Okay. So velocity at any point of A, tangent direction of A will be same as velocity at tangent direction of B. It's a transmission of velocity. Right? Again, this we are still at the early stage of chapter 5. The question already mentioned, do not slip. In later, you learn more and more, there will be a question, you say belt will slip at a certain time. Okay, so that another solution already. In this case, in example 2, transmission belt do not slip means you can transfer your information from one body to another body, especially velocity. Okay? Okay, so the only thing that link to body is the velocity. Why omega doesn't change? Because omega link with the radius. There's a different radius here. So omega doesn't change. Omega is not same because of the radius of the body. Okay, so V equal to omega R at A, same as omega at B. We substitute the value. Velocity, so you link lah, this one. So you have omega R at A and B. You already have omega at A. So omega A is 7 point something radian per second. R of A is given in the diagram, 0.5. Again, you use unit SI, you're using meter. In coming test or final exam, you will see mm. We purposely put millimeter. So when you see millimeter, you still need to change into unit SI. Okay. Okay. So then omega B is missing. R you have, so there's only one unknown here. You press calculator, you can able to find your omega B. Okay. So once you know how this wheel turns with omega, you know the V, you know the omega, but one thing you don't know, again, rigid body, you need omega and alpha. For any body, any component or any rigid body, you need two information, alpha and omega. So if you don't have that, go and find it out, right? So equation already write on the whiteboard here. Okay, so you transfer, you look at the question, anything that is missing, refer to the equation, then it and transfer to another one. Just confuse omega and alpha. Omega and alpha, they link to the radius. So as long as the radius change, omega alpha will not same. But if there any belt linked to the two body, velocity will be the same along the belt. The belt will move in the same velocity. Okay. So here we have the omega of two bodies. Then we find alpha. Acceleration at the point of A and B will be the same like velocity because it's the belt. So velocity and acceleration will be the same. So you link acceleration at tangent direction. Okay, now tangent direction is alpha r. Normal direction is omega squared r. Don't confuse between these two. This will be the careless mistakes usually I see in the final exam. Okay, you confuse with tangent and normal. You use the wrong equation, then the rest is wrong. Okay, so this one, alpha. equal to in tangent direction, acceleration will equal to alpha r. Alpha r. A and B same. So you already have your alpha r in the question. You substitute your alpha r, alpha A, radius you already know, alpha B you don't know, angular acceleration you don't know, radius you know. So from here also you can find the missing component. Okay, remember to put the unit. Acceleration is meter per second square. In this case, is angular acceleration. Angular we do radian per second square in radian. Okay. So the question asks you to focus on point P. Yeah. So as you can see, so far, how we begin to solve, we look at a general perspective. We look at, okay, in this case, we have two bodies and link with the pulley. Then we try to find the alpha, omega, velocity, acceleration for that body. One body, then you move to another bodies. You transfer information to another bodies. Then you look at the question, what question you want to ask you. In this case, it's point P. Okay, point P. So it asks you what happened to this P. All right. So after pulley have turned 2 revolution. So you go to the point P. This is a circular motion. So circular motion straight away, you draw 2 axes, tangent and normal. So tangent acceleration, you can convert to angular. All right. Angular acceleration in tangent direction equal to alpha r. Normal direction equal to omega square r. So you already have the value for the wheel here, omega and alpha. Just substitute the value there. Okay. So Vp equal to omega r. Just substitute. Then alpha. Okay. And so on. Okay. That's the application of formula. Okay. So try to understand the concept and the way we solve. Don't memorize the value. Right? Try to understand what are the standard procedures. There's certain ways of doing your solution in engineering solution. Then you know that these are two vector. Normal tangent direction is a vector. You need to find the magnitude. Square tangent, square normal, square root, you get the magnitude. Okay. If the question asks you the direction of the acceleration, you should be able to find by finding the angle of this one. So you should be able to find by tangent direction. Now, some of you, you're still very weak in trigonometry equation. Okay. So later during the break, I will distribute the test one. You will see. So if you're still weak in cos and sine, please polish up it before it come to final. Okay, so this is how you solve for the normal scenario of velocity, acceleration, linked with the omega and alpha. Okay. All right. Now, this is just a recall of what we learned previously. Motion of rigid body, you have a few. Translation, you have 2 types. I mean by translation, there's no change of rotation or orientation of the bodies, either in straight line or in circular motion. Another one is rotation. Rotation is around the bodies. Okay. Then general plane is a mixture of 2. Okay. Now we look at general plane motion. So when general motion is combined translation and rotation, so we split our analysis steps into two major components. one, you analyze using translation, followed by rotation steps. Okay? Or you can start with rotation, then you start with translation, also same. Okay. But usually we start with translation, then rotation. Okay. So these are the equation that you should be familiar. What is velocity definition? What is acceleration definition? What is the angular velocity definition? What is the acceleration and angular acceleration definition? Right? Okay. Now we go into absolute motion analysis. For example, this is a dump truck that the arm can be extend and then rotate this bin here. Okay, so there are some parameter, 2 point, piston A, location A and B. Then the C at the pivot point of the bin. So there's another piston here, right? Another piston. B to C is another piston. A to B is another piston. So there's a displacement distance S here from the position B to the pivot point C. Then there's a distance between A and C. Then there's an angle change whenever you change the angle of the bin. Okay, so this one is just an illustration, all right? So this one you read now, this one you read. Just want to show you, we can derive one equation to link S with your cosine rules. This is a triangular, which is not right triangular. Okay, it's not a right triangular. So when you do not have a right triangular, you cannot use the normal sine cos tangent anymore. But when you have a change of shape of triangular, right? It's still a triangular, but it's not a right angle. You need to use cosine rules. So for rigid body, if you're not familiar or you're very weak in cosine rules, go and flip the the triangular shape that is non-normal one. Okay. Meaning there's one chapter in mathematics that it is not right angle one. This is tan, sine, cos. Yeah, but in rigid body, you need to use cosine rules. It will be alpha, this is A, this is B, this is C, and so on. Go and find out what is cosine rules. Okay, so we already assume you already know what is this one when you come to engineering dynamic class. So to find the distance of S, we use square root of A square plus B square minus 2AB cos theta. This can be found in your mathematics textbook. So I'm not going to prove this relationship anymore. Right? Okay. So once you have your S here, you know that when you have displacement, you can find velocity, you can find acceleration, and so on, right? And you can link this one. If this one rotates, there's a change of angle. Change of angle, you have the R, then you can find your V, omega, alpha, and so on. Okay, now we look at example number 3. So example number 3, you see a spring and you see a round body. So end of the rod R maintain contact with the cam by the mean of the spring. This basically is you can say this one as your brake system. If the cam rotate about an axis passing through point O with angular acceleration alpha and angular velocity omega. Determine the velocity and acceleration of the rod. It tells you velocity and acceleration and not angular velocity and acceleration. So when you see this normal velocity and acceleration without angular, again, link back to these two equations right on the whiteboard here. Velocity equal to V equal to omega R. Acceleration, you have two components, tangent and normal direction. Okay, So AT equal to alpha R, AN equal to omega square R. If the thing move in straight line, you only see tangent direction. Okay? When the object move in straight line, you only see tangent direction. There's no more normal direction. Okay? If you don't understand this one, go back to chapter 2 slides. Okay? Okay, he asks you to find the V and A of the rod when the cam is in the arbitrary position theta. Here. This one, move to here. Then you're having the rotation of the cam, which is alpha and omega in the clockwise direction. Okay. So we need to define our rotation motion. So in this case, on the diagram, you know that you have OA with the radius. C is the distance moved by the cam. C is moved from here to here. All right. So the cam, the focus here is the cam, the rod. The cam move in a circular motion, but the cam move in the linear motion. So linear motion, you are having translation. Okay. And all our calculation, we calculate based on fixed point O here. So you can derive equation from this one is a right angle triangular. So OC equal to CB, and you can use cos rules, right? So CB or OC equal to R cos theta. Your X equal to 2 times of R cos theta, right? So once you have the position of X, right, or displacement equation, right, displacement equation, X will be linked to radius and cos theta, right? So this one, if you see something that link rotation to linear, this is how you do it lah. Okay, you try to build a triangular, then to find the change of angle between these two. Huh? So once you have the X equal to something R theta, you need to find velocity, right? So velocity is dx dt or ds dt. Acceleration equal to dx square divided by dt square, right? So you need to do differentiation here. You have two term here. 2r, one term, cos one term. So 2r is u, cos is v. You need to use chain rules to solve this one. Okay, so again, the chain rules, how you do it is in appendix, in Canvas. Go and see, right? So when you use chain rules, you're going to get this answer. Okay, so when you do chain rules, right? So I'm not going to explain how to do chain rules already, right? So V equal to, after you do chain rule, you get these steps. Then your velocity, you arrive at minus 2r omega sine theta. What is omega? Because when you do chain rules, you differentiate the angle, you get d theta dt. D theta dt is omega. Okay, once you get your V, you continue to do your acceleration. Again, it's a chain rules again. This is U, this is V. You do the UV procedure. It's a long step. Okay. Again, mathematics step won't be given, won't be provided in this module. This is not mathematics class anymore, so you won't see the appendix in the question on how to do chain rules. So we assume you already know already. So this is the steps. So you do the steps, you arrive at one lengthy equation for A, A equal to minus 2R something and something. Okay. Now, what is important for this slide is that there is a high chance possibility you need to use chain rules for your test 2 and final exam. Okay. Okay. Then for this example 3, what need to take home is that you can link linear translation with the R and theta by deriving a very simple triangular relationship. This is the right angle. No? This is a very simple direct case. Again, I show you the previous slides. Go and home and study cosine rules. You need to relate. In this case, it's right angled because it's x. Like the example just now, the bin truck, the x is, you need to follow cosine rules. You need to find like square root of something and something. So then it will give you chain rules are very complicated. Okay. So basically these are the steps. So minus sign here indicate that V and A are opposite direction in the position of X. Okay. It's a vector form. Okay. When you see vector form, means the direction is a bit different from the direction of the X. So here, it gives you X positive direction. You see the arrow here. This is the datum, although the question do not purposely put datum here. This is the datum positive to the left-hand side. Okay, so as we move on again, when you go deeper and deeper, the question will not purposely mention important information for you. For example, this case, example 3, datum is not written here. It's a datum. Okay, so look carefully. Okay, another one. Okay, now this one is window, hydraulic window that in the hostel, maybe you have this kind, or in your room, you have this kind of window, when you can able to push it with the piston. Or you can imagine this one as your car, either the back mirror, right, the back. Okay, so large window open using hydraulic cylinder AB. This is A, this is B, hydraulic piston here. So if the cylinder extend at a constant rate, so this one extend at a constant rate, 0.5 meter per second. You have a constant rate means you have the V here. It's a V. Determine the angular velocity and angular acceleration of the window at the instant of 30 degrees. So if this one expand, window will open, degree will, the angle here will changes. So angle here changes, you will get angular velocity and angular acceleration, right? So it asks you when at 30 degree, what is the omega and alpha for this window? Huh? Okay. So how you solve? You fix the location that you are focused on. Okay, so these are the angle as you see on the diagram. So the window motion change with the angle theta. Hydraulic cylinder, you move with the S. So these are the things that link these two things. In this case, we can no longer use the right angle triangular relationship. This we need to use the law of cosines because we don't have a right angle triangular. Okay, so again, this is the equation. C square equal to B square plus A square plus B square minus 2AB cos C, and these are the angle A, capital ABC is an angle that is missing. Small capital or small alphabet A, B, C, they are the length of the triangular. Okay, so this basically is a cosine rules. Okay, so you put inside there S square equal to OA square plus B square minus 2OA AO BO cos theta. You convert this triangular. A, B, O back to A with this angle, link with this cosine rules. You want to find C, right? This one, S, is in front of the angle, right? In front of the angle. So you back to the cosine rules. This is the angle. You want to find S. So you change a little bit. So let's say you want to find C. The in front one is S. So this is C, right? So C to C. So you write this equation. Okay. So C is your S. What is your A? A is here. A is your this one, OB. This one, B is your OA minus 2AB cos C. C is this angle you want to find. Okay. So you do lah. Okay. You do your calculation, substitute. You know OB, AB, substitute there, cos theta. Okay. Theta is 30 degrees. Okay. Okay. 30 degrees. You assume at the instant this degree. Okay. So at that instant, your S is become this one. Ignore the A here. Huh? Should be something. Huh? I think the answer should be 1.2 something. Okay. So once you have that equation, S square equal to that one. You have the S. You want to find velocity is ds dt, time differential. Okay, ds dt. Again, this is not acceleration. This square here, because the question already start with S square. Okay. So we tie this one, you get this one. So inside chain rules, you dt v square, there's a chain rules shortcut there. dv dv square dt, you can write 2v dt dv equal to 2va. Okay, there's a step inside chain rules. So on my slide, I just give you the reminder, then I just apply the equation. Okay. Okay. Then you solve ds dt. ds dt, you get v. Okay, here you need to do some differentiation for cos. And then you arrive at one equation. So you have a boundary condition at 30 degree, velocity is 0.5. Because here it tell you that velocity is 0.5. You put it inside there, you can find the omega. Okay. Again, if you're not familiar with chain rules, go home and go and read about chain rules. Okay. Of course, say, sir, can I move square here to another side? You can. S equal to root 5 minus 4 cos theta. But when you do time differentiation, you need to be careful. You have consider the square root. You're actually solving a more complex chain reaction there. Okay. So you have two equations. Okay, you have two equations, equation 1 and equation 2. Then you take time differentiation. STT. Okay, you do time differentiation. You arrive at very lengthy steps. Okay, I will skip all the things. You go home and look at it. Then you arrive at one boundary condition. Acceleration of your piston will be 0 because you have a constant rate of velocity. When you have a constant rate of when you have a fixed v, when you differentiate your v with time, you get 0. So this one also already asked you in the test one question. When you have a constant acceleration, what happened to your velocity, right? Or you have a constant velocity, what happened to your acceleration, right? So Vs equal to so and so, you just substitute and you find alpha equal to minus something, okay? Right. So when you get a minus, there's a deceleration happen in the window. Means at 30°, it will slow down. Although this one moved at a constant rate, at the beginning, it moved very, very fast. But when you reach 30°, it start to slow down. That's why in your calculation, you get negative. Okay. So this one, a question you need to explain. The question will also guide you. Explain the behavior, explain the end motion of the window. This is the expected answer. If you get positive, what mean by positive? If you get negative, what mean by the negative? Okay. Okay. So next one is relative motion analysis velocity. Again, there's a shortcut. So when you have a fixed reference and translating reference means you stand here, but your friend is running around. Okay. So you have a distant reference from your position O here to the body and a position to point A. Means you can see this one as one body. You have head and toe, or head and feet. So the distance between head and feet always same, but head and feet have a relationship with this RB stroke A. RB stroke A is distance to B from A. Distance of B from A is a different from R. So if you answer, you write A stroke B and your arrow is pointing this way, you get the wrong answer. This one, you see the angle pointing, notation is RB stroke A. Be careful on your notation. Okay, then RB, RA. So again, there's a cheat code. Vector relationship. You just transfer the slash into negative. Okay, the rest you read. So how you know position of B? Position of B will give you RB plus RA plus this one. Okay, RB is the resultant. How you know? How you draw resultant vector diagram? RB is a resultant start to finish. How you reach from O to B? You need to travel from O to A, then from A to B. This is the vector relationship. Okay. So once you have the position of B, okay, now we start to move B already. Move the rod. Move the rod. If you move the rod A, B, we move the rod. We try to rotate this rod vertical. Okay, we try to rotate this rod vertical by moving this rod to from here to here. So when we move this rod like this orientation to this orientation. A is travel with a certain distance, with this DRA. It's a distance traveled at the point A, or your head travel at a certain distance from its original position. Same with B. B also travel dr dB. Plane motion, it combine translation plus rotation at the same time. So how we dissect this question? How this motion come to here is like you're making a movie. You slow it down and then you dissect. So the body of AB, translation move to this side first. Means A move to A side first, to A position, but still in certain, stay with the orientation. This one move to here. Then to finish the motion, this one have to rotate. Okay, you see the dot line here, it have to rotate at a certain angle. Then you will reach the final position. That's why this is called general plane motion. Okay, so the R is the same. The first translation motion move here to here. The R distance travel is the same. This one also same. But the complicated part is when it start to rotate. When this one rotate, there's a change of angle, d theta here, from this to here. Then here also, here is from B dash to B. The distance you write drb stroke A. And this is the distance traveled from from B to B. So there are two vector diagram here, and another one is here. Okay, so we try to make it mathematically. Okay, so this one already explained how the thing move. Okay, now due to rotation about A, this one rotate here. So you can write this one equal to R multiplied by d theta. This equation is a small section of relationship. So you use the same. How you find the distance traveled here, B comma to B. This is a small, you can say this one is a small rotation. So small rotation, you can use S equal to R theta. So this is the S, this is the R, this is the theta, this is the theta. So drb stroke A equal to R theta. Okay. Then displacement of B, this one. This is a vector diagram. So this is the resultant. Okay. How you get the RB, or this arrow is a combination of this arrow and this arrow. So you copy this one plus this one. I get this relationship. Okay. So this one, the RB is due to translation and rotation. From this point to this point, it need it need to translate and rotate, because it's here, translate here, rotate here. The A is translation of A. This one is translation. Okay. So velocity, still the same concept. When you have displacement equation, you want to do velocity, you do time differentiation. So again, chain rules apply here. So dr dt, this one dr dt, this one dra dt, the RAB with this one. Again, previously, is there any changes between your eyes distance or your head to neck distance? No, right? The distance here remains same. So you can cancel, actually you can cancel this one. Okay. Okay. So at the end, you still get VA equal to VA plus VA. We all just change the code here. When you see something slash something, change the slash into minus. Okay. So dr dt is actually is r dr dt. You differentiate theta, this one, rb stroke a, rb stroke a, this one. This one equal to s equal to r theta. This one is s equal to s theta. So this one you can write as r theta, but you differentiate with time. R is the same, is a constant value. This one is the constant value. So you pull out, then you differentiate the angle. This one is omega. Right, this one is omega. So magnitude of V, again, V equal to omega R, but you still look at what you want to study. You still use back the V equal to omega R. Direction of this velocity is perpendicular to the R. This one, VBR is perpendicular, or you can just see it as a tangent direction. This is a circular motion. It's always tangent to the curve. Okay. So general plane, no matter how it do, it consists of translation and rotation. So let's say this object, it rotate this way, and the path of A move from here, B move up. So it rotate like that. Okay. When you rotate like that, you can transfer the motion into translation, means move this direction plus rotation at fixed point A. Okay. So you have VB equal to VA plus BA stroke A with this relationship. Then the cross product come in and so on. So this one, you just use what you see on the screen here. So V stroke A, if you want to write in the vector form, you need to use the cross product, or you need to use when you see cross means you need to use the vector approach. Vector approach means you need to open up the matrix form and solve it. Okay, we have a short break, then we continue. 5. Okay, we stop for maybe 5 minutes, then we continue.